Hi, and welcome back to our discussion on the 8 standards for math practice. These are the standards that help us become good mathematicians, because these are the standards that good mathematicians follow when they do math. Let's review what we've learned so far. Math practice 1 is make sense of problems and persevere in solving them. We can make sense of problems by doing whatever we can to understand what it means. Sometimes that means rereading it, sometimes that means visualizing it, or other problem-solving strategies like drawing it out, acting it out, highlighting keywords, whatever it takes, we want to make sense of that problem. And then persevere in solving them means no matter how hard the problem is, we're going to keep on working until it's done. We stop because we're done. We don't stop because it's hard. Math practice 2 is reason abstractly and quantitatively. We have these images here to remind us that abstract and quantitative are both representations of the same thing. Quantitative refers to the real life, using units of measure and realizing that we do math to answer questions about the real world. Quantitative is us using symbols or other abstract representations to help us answer the questions that we have about real life. So these are very connected. Math practice 3 is construct viable arguments and critique the reasoning of others. The best way that we can construct viable arguments is to show our work. Whenever we show our work, we're showing how we got from point A to point B, and we're proving that we know what we know. When we critique the reasoning of others, we're not always looking for mistakes that are made. Sometimes we're learning from them. When we're looking and evaluating the work of others, we can learn a lot from that, whether it's right or whether it's wrong. Math practice 4 is model with mathematics. That means that we're using a bunch of different representations to answer mathematical questions. Some of those representations might include graphs, tables, equations, even pictures, or using words, that quantitative relationship. Math practice 5 is use appropriate tools strategically. There are a variety of math tools available to us, including calculators, our own brain, measurement devices, our own notes that we take, and we need to make sure that we're using all of the appropriate tools at the appropriate times and that we're using them in the right ways. And now we're ready to review our most recent one, Math Practice 6, which is attend to precision. This means that we're being precise in our definitions, we're being precise in the vocabulary that we use, we're making precise diagrams, and we're trying to be as accurate and correct as possible. But precision isn't just accuracy, it's also clarity and being specific. So just like we're using appropriate tools, we want to use appropriate words. That's tying into that precision. And now we're ready for Math Practice 7. When we do these math practice notes, remember we're taking them in this way, where we start with the math practice number and what it says. We'll clarify any words that we don't understand. This time we're going to do an activity or an example to help us understand, and then we'll put it in our own words. After that, we'll have a reflection piece, which I will help you with, where we're going to set some goals on how we can be better at doing this particular math practice. And now, here is Math Practice 7. Make sure you're writing this down. Math Practice 7 is look for and make use of structure. And yes, I do want you to be writing this down. So one last reminder, if at any point I'm going too fast, if at any point I move on and you haven't written down what you see on the screen, then pause the video and make sure it's written down so that you can be a good note taker. Look for and make use of structure. We start with an example. If 2 plus 5 equals, and we all know that 2 plus 5 is equal to 7, then it makes sense that 2 cats plus 5 cats is equal to 7 cats. And we can further make sense of this. If I have 200 plus 500, we know that that's going to be equal to 700. It makes sense because we're making use of the structure. We know that 2 plus 5 is 7, so no matter what type of thing I'm adding, if there's 2 of that thing and 5 of that thing, then I'm going to end up with 7 of that thing. So continuing on, we can also have 2 pi plus 5 pi, and it makes sense that that's going to equal 7 pi. And if it's 2 hearts plus 5 hearts, we're not surprised at all when we get the result of 7 hearts. And 2 tenths plus 5 tenths, again, you're not surprised, and you know that that is 7 tenths. So with all that, it's very interesting that when students start adding fractions and they see this, the first time they do it, they say it's 7/20. But when you really stop and look at the structure, 2 plus 5 is 7, so 200 plus 500 is 700, and 2 pi plus 5 pi is 7 pi, and 2 hearts plus 5 hearts is 7 hearts. 2 tenths plus 5 tenths is still, of course, 7 tenths, even if we write it like this. 2 tenths plus 5 tenths is really 7 tenths, because we're adding the same thing. 2 plus 5 is 7, no matter what it is that we're adding together. That is making use of structure. How much simpler would it have been to learn fractions and understand why we need that common denominator, and that when we have that common denominator, it stays the same in an addition problem if we were able to learn that using that mathematical structure. Here's your next example. I am wanting to compare these two expressions, 34 plus 217 and 18 plus 217. Which of these symbols belongs there to compare them? Are they equal? Is one bigger or smaller than the other? I want you to understand that we really don't even have to calculate in order to see this. If we really look at the structure, we're going to see that the appropriate symbol here is the greater than symbol, because we can see 217 is part of both of those expressions. So I don't need to bother with that 217. I don't need to use the actual calculator to calculate these expressions, because I see that the structure in both of these is similar. That means the only pieces I really need to compare are 18 and 34. And I know that 34 is greater than 18, so I know 34 plus 217 is going to be greater than 18 plus 217. And we can do that, again, very quickly without calculating, because we're looking for the structure of the mathematics. Here's example 3. I want you to use mental math. That means that we're using the structure of mathematics, and I want you to mentally calculate 34 times 5. Now, when I say mentally calculate 34 times 5, I don't mean do the standard algorithm in your head. I don't want you to stack it. I don't want you to think about doing this and carrying the 2. That's not what I have in mind. How can you mentally figure out 34 times 5 without using a calculator? Pause the video and give yourself a chance to figure it out. How are you doing it mentally? And give yourself a chance to do this. Pause the video before watching the rest. How are you going to calculate this mentally? Hopefully, what you did when you paused the video is you recognized that 34 is composed of 3 tens to make 30 and 4 ones. Add those together and you get 34. And thinking about 34 in this way also allows us to break up the multiplication into smaller pieces that are easier to mentally calculate. We can start by multiplying the 4 and the 5 to get 20, and then multiply the 30 with the 5 to get 150. Now that I've broken up those two pieces and calculated those individually, then it's really easy to add those pieces together and figure out that 34 times 5 is equal to 170. You're able to do this because you recognize the structure of mathematics. You recognize that 34 is 30 and 4. So when you're multiplying 34 by 5, you can multiply 30 by 5 and multiply 4 by 5, because those are a little bit smaller and easier to calculate. We're now ready to write this math practice in our own words. This math practice means, now this one is a tough one. It's hard to figure out what we mean by look for and make use of structure. So look back at our examples. When I'm talking about structure, I like to think of how something is built. Specifically, how is mathematics built? How are numbers built? Can we compose and decompose them to make more sense of them? So structure refers to how things are built or composed. Hopefully that helps when we say look for and make use of structure. Now again, this one is tricky, but I still want you to do your best. Don't forget that this is your Canvas homework. So after you're done watching this video, anything that you're writing down now for what this math practice means, this is going to go into Canvas. I'll be sure to give you some really good feedback to let you know if you have a good understanding of what this math practice means. And here's some hints. When I talk about the reflection and give you some ideas on what you can write down for your reflection, that will also give you some clues on how to interpret this math practice. I can look for and make use of structure by, make sure you write this in your notes. Let's reflect. I can look for and make use of structure by using what I know about math to break up a problem. When we break up that problem, it does help us see it in a little bit different way, and that can give us some good clues. Think about the specific examples that we went through. I can look for and make use of structure by composing and decomposing numbers. Those are some good ways that you can reflect on Math Practice 7, and hopefully that also helps you understand it a little bit better so that you can put it in your own words. That's it for today and Math Practice 7. Look for and make use of structure. Thanks, and we'll see you next time.